So let's go back and try number 1. Same beginning, which is I have to get x by itself. This time it's being multiplied by the square root of 2. So to undo that, I just divide by the square root of 2. Divide by the square root of 2. Cancels. And I'm left with x equals 8 over the square root of 2. And that is a problem. We cannot have a radical as the denominator. Let's say it again. We cannot have a radical as the denominator. All right, so I have to figure out how to get that out from the denominator. I'm just going to rewrite this way so I have more room on the board. Okay. Basically, the procedure is this. I'm going to multiply this whole thing by square root of 2 over the square root of 2. Okay, there's 2 reasons I can do that. First of all, any number over itself equals 1. Think about it. 6 over 6 equals 1. 10 over 10 equals 1. So I'm just multiplying this by 1, so I'm not changing the value. I'm just using that to get the radical out of the denominator. Secondly, the reason I'm doing this is because think about it. What is the square root of 2 times the square root of 2? When you have numbers under a radical, you multiply them. So that would be the square root of 4. And the square root of 4 is 2. So that solves the problem. Let's do it together. All right. I multiply by the square root of 2 over 2. As the numerator, I get 8 times the square root of 2, which is just 8 times the square root of 2. On the bottom, I get square root of 4 because you can multiply what's underneath. All right. One more time. That's still there. And the bottom square root of 4 is 2. So see, I have gotten rid of the radical as the denominator. We have one more step. Anything outside of the radical can still reduce, just as if I had 8 over 2. So I just simplify. 2 goes into 2 once, 2 goes into 8 4 times. So my final answer is 4 times the square root of 2. We can't touch what's in here, but we can reduce anything outside the radical. All right.